Mercury is a chemical element with symbol Hg and atomic number 80. It is commonly known as quicksilver and was formerly named hydrargyrum, a heavy, silvery D-block element. Mercury is the only metallic element that is liquid at standard conditions for temperature and pressure. The only other element that is liquid under these conditions is bromine. Though metals such as caesium, gallium, and rubidium melt just above room temperature, mercury occurs in deposits throughout the world mostly as cinnabar. The red pigment vermilion is obtained by grinding natural cinnabar, synthetic mercuric sulfide. Mercury is used in thermometers, barometers, manometers, sphygmomanometers, float valves, mercury switches, mercury relays, fluorescent lamps, and other devices. Though concerns about the element's toxicity have led to mercury thermometers and sphygmomanometers being largely phased out in clinical environments in favor of alternatives such as alcohol or Gallium-filled glass thermometers and thermistor or infrared-based electronic instruments. Likewise, mechanical pressure gauges and electronic strain gauge sensors have replaced mercury sphygmomanometers. Mercury remains in use in scientific research applications and in amalgam for dental restoration in some locales. It is used in fluorescent lighting. Electricity passed through mercury vapor in a fluorescent lamp produces shortwave ultraviolet light, which then causes the phosphor in the tube to fluoresce, making visible light. Mercury poisoning can result from exposure to water-soluble forms of mercury, by inhalation of mercury vapor, or by ingesting any form of mercury. Properties. Physical properties. Mercury is a heavy, silvery white liquid metal. Compared to other metals, it is a poor conductor of heat, but a fair conductor of electricity. It has a freezing point of -38.83 degrees Celsius and a boiling point of 356.73 degrees Celsius, both exceptionally low for a metal. In addition, mercury's boiling point of 629.88 K is the lowest of any metal. Upon freezing, the volume of mercury decreases by 3.59% and its density changes from 13.69 grams per cc when liquid to 14.184 grams per cc when solid. The coefficient of volume expansion is 181.59 times 10⁻⁶ at 0 degrees Celsius, 181.71 times 10⁻⁶ at 20 degrees Celsius, and 182.50 times 10⁻⁶ at 100 degrees Celsius. Solid mercury is malleable and ductile and can be cut with a knife. A complete explanation of mercury's extreme volatility delves deep into the realm of quantum physics, but it can be summarized as follows. Mercury has a unique electron configuration where electrons fill up all the available 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, and 6s subshells. Because this configuration strongly resists removal of an electron, mercury behaves similarly to noble gases, which form weak bonds and hence melt at low temperatures. The stability of the 6s shell is due to the presence of a filled 4f shell. An f shell poorly screens the nuclear charge that increases the attractive Coulomb interaction of the 6s shell and the nucleus. The absence of a filled inner f shell is the reason for the somewhat higher melting temperature of cadmium and zinc, although both these metals still melt easily and, in addition, have unusually low boiling points. Chemical properties. Mercury does not react with most acids, such as dilute sulfuric acid, Although oxidizing acids such as concentrated sulfuric acid and nitric acid or aqua regia dissolve it to give sulfate, nitrate, and chloride. Like silver, mercury reacts with atmospheric hydrogen sulfide. Mercury reacts with solid sulfur flakes, which are used in mercury spill kits to absorb mercury. Amalgams. Mercury dissolves many other metals such as gold and silver to form amalgams. Iron is an exception, and iron flasks have traditionally been used to trade mercury. Several other first-row transition metals, with the exception of manganese, copper and zinc, are reluctant to form amalgams. Other elements that do not readily form amalgams with mercury include platinum. Sodium amalgam is a common reducing agent in organic synthesis, and is also used in high-pressure sodium lamps. Mercury readily combines with aluminium to form a mercury-aluminium amalgam when the two pure metals come into contact. Since the amalgam destroys the aluminium oxide layer which protects metallic aluminium from oxidizing in depth, even small amounts of mercury can seriously corrode aluminium. For this reason, mercury is not allowed aboard an aircraft under most circumstances because of the risk of it forming an amalgam with exposed aluminium parts in the aircraft. Mercury embrittlement is the most common type of liquid metal embrittlement. Isotopes. There are 7 stable isotopes of mercury, with 202 Hg being the most abundant. The longest-lived radioisotopes are 194 Hg with a half-life of 444 years, and 203 Hg with a half-life of 46.612 days. Most of the remaining radioisotopes have half-lives that are less than a day. 199 Hg and 201 Hg are the most often studied NMR active nuclei, having spins of 1/2 and 3/2 respectively. Etymology. Hg is the modern chemical symbol for mercury. It comes from hydrargyrum, a Latinized form of the Greek word delta rho alpha rho gamma upsilon rho omicron sigma, which is a compound word meaning water silver, since it is liquid like water and shiny like silver. The element was named after the Roman god Mercury, known for his speed and mobility. It is associated with the planet Mercury. The astrological symbol for the planet is also one of the alchemical symbols for the metal. The Sanskrit word for alchemy is rasivatam, which means the way of Mercury. Mercury is the only metal for which the alchemical planetary name became the common name. History. Mercury was found in Egyptian tombs that date from 1500 BC. In China and Tibet, mercury use was thought to prolong life, heal fractures, and maintain generally good health. Although it is now known that exposure to mercury vapor leads to serious adverse health effects. The first emperor of China, Qin Shi Huang Di, allegedly buried in a tomb the mausoleum of the first Qin emperor that contained rivers of flowing mercury on a model of the land he ruled. Representative of the rivers of China was killed by drinking a mercury and powdered jade mixture formulated by Qin alchemists who intended to give him eternal life. Komaraway ibn Ahmad ibn Tulun, the second Tulunid ruler of Egypt, known for his extravagance and profligacy, reportedly built a basin filled with mercury, on which he would lie on top of air-filled cushions and be rocked to sleep. In November 2014, large quantities of mercury were discovered in a chamber 60 feet below the 1800-year-old pyramid known as the Temple of the Feathered Serpent, the third largest pyramid of Teotihuacan, Mexico, along with jade statues, jaguar remains, a box filled with carved shells and rubber balls. The ancient Greeks used mercury in ointments. The ancient Egyptians and the Romans used it in cosmetics. In Lamani, once a major city of the Maya civilization, a pool of mercury was found under a marker in a Mesoamerican bulkcourt. By 500 BC, mercury was used to make amalgams with other metals. Alchemists thought of mercury as the first matter from which all metals were formed. They believed that different metals could be produced by varying the quality and quantity of sulfur contained within the mercury. The purest of these was gold, and mercury was called for in attempts at the transmutation of base metals into gold, which was the goal of many alchemists. The mines in Almaden, Monte Amiata, and Idria dominated mercury production from the opening of the mine in Almaden 2,500 years ago, until new deposits were found at the end of the 19th century. Occurrence: mercury is an extremely rare element in Earth's crust, having an average crustal abundance by mass of only 0.08 parts per million. Because it does not blend geochemically with those elements that constitute the majority of the crustal mass, mercury ores can be extraordinarily concentrated considering the element's abundance in ordinary rock. The richest mercury ores contain up to 2.5% mercury by mass, and even the leanest concentrated deposits are at least 0.1% mercury. It is found either as a native metal or in cinnabar, cordierite, livingsteinite and other minerals, with cinnabar being the most common ore. Mercury ores usually occur in very young orogenic belts where rocks of high density are forced to the crust of Earth, often in hot springs or other volcanic regions. Beginning in 1558, with the invention of the patio process to extract silver from ore using mercury, mercury became an essential resource in the economy of Spain and its American colonies. Mercury was used to extract silver from the lucrative mines in New Spain and Peru. Initially, the Spanish crown's mines in Almaden in southern Spain supplied all the mercury for the colonies. Mercury deposits were discovered in the New World, and more than 100,000 tons of mercury were mined from the region of Huancavelica, Peru, over the course of 3 centuries following the discovery of deposits there in 1563. The patio process and later pan-amalgamation process continued to create great demand for mercury to treat silver ores until the late 19th century. Former mines in Italy, the United States and Mexico, which once produced a large proportion of the world's supply, have now been completely mined out or, in the case of Slovenia and Spain, shut down due to the fall of the price of mercury. Nevada's McDermott mine, the last mercury mine in the United States, closed in 1992. The price of mercury has been highly volatile over the years and in 2006 was $650 per 76-pound flask. Mercury is extracted by heating cinnabar in a current of air and condensing the vapor. The equation for this extraction is mercury 2 sulfide plus O2Hg plus SO2. In 2005, China was the top producer of mercury with almost 2/3 global share, followed by Kyrgyzstan. Several other countries are believed to have unrecorded production of mercury from copper electrowinning processes and by recovery from effluents. Because of the high toxicity of mercury, both the mining of cinnabar and refining for mercury are hazardous and historic causes of mercury poisoning. In China, prison labor was used by a private mining company as recently as the 1950s to create new cinnabar mines. Thousands of prisoners were used by the Luoxi Mining Company to establish new tunnels. Worker health in functioning mines is at high risk. The European Union directive calling for compact fluorescent bulbs to be made mandatory by 2012 has encouraged China to reopen cinnabar mines to obtain the mercury required for CFL bulb manufacture. Environmental dangers have been a concern, particularly in the southern cities of Foshan and Guangzhou, and in Guizhou province in the southwest. Abandoned mercury mine processing sites often contain very hazardous waste piles of roasted cinnabar calcines. Water runoff from such sites is a recognized source of ecological damage. Former mercury mines may be suited for constructive reuse. For example, in 1976 Santa Clara County, California purchased the historic Almaden quicksilver mine and created a county park on the site. After conducting extensive safety and environmental analysis of the property, chemistry, mercury exists in two main oxidation states, iron 2. Higher oxidation states are rare fluoride, mercury 1 fluoride, 4, but have been detected under extraordinary conditions. Compounds of mercury. Unlike its lighter neighbors cadmium and zinc, mercury usually forms simple stable compounds with metal-metal bonds. Most mercury compounds are diamagnetic and feature the dimeric cation Hg2+2. Stable derivatives include the chloride and nitrate treatment of Hg compounds, complexation with strong ligands such as sulfide, cyanide, etc. Induces disproportionation to Hg2+ and elemental mercury. Mercury chloride, a colorless solid also known as calomel, is really the compound with the formula with the connectivity ClHgHgCl. It is a standard in electrochemistry. It reacts with chlorine to give mercuric chloride, which resists further oxidation. Mercury hydride, a colorless gas, has the formula mercury 1 hydride, containing no Hg-Hg bond. Indicative of its tendency to bond to itself, mercury forms mercury polycations, which consist of linear chains of mercury centers, capped with a positive charge. One example is Hg2+, 3, AsF-6, 2. Compounds of mercury. Mercury is the most common oxidation state and is the main one in nature as well. All four mercuric halides are known. They form tetrahedral complexes with other ligands, but the halides adopt linear coordination geometry, somewhat like Ag+ does. Best known is mercury chloride, an easily sublimating white solid. Mercury 2 chloride forms coordination complexes that are typically tetrahedral, e.g. mercury 2 chloride -4. Mercury oxide, the main oxide of mercury, arises when the metal is exposed to air for long periods at elevated temperatures. It reverts to the elements upon heating near 400 degrees Celsius, as was demonstrated by Joseph Priestley in an early synthesis of pure oxygen. Hydroxides of mercury are poorly characterized, as they are for its neighbors gold and silver. Being a soft metal, mercury forms very stable derivatives with the heavier chalcogens. Preeminent is mercury sulfide, mercury 2 sulfide, which occurs in nature as the ore cinnabar and is the brilliant pigment vermilion. Like zinc sulfide, mercury 2 sulfide crystallizes in two forms, the reddish cubic form and a black zinc blende form. Mercury selenide and mercury telluride are also known. These, as well as various derivatives, e.g., mercury cadmium telluride and mercury zinc telluride, being semiconductors useful as infrared detector materials. Mercury salts form a variety of complex derivatives with ammonia. These include Millen's base, the one-dimensional polymer salts of HgNH+2N, and fusible white precipitate, or Cl2. Known as Nessler's reagent, potassium tetraiodomercurate mercury 2 iodide -4 is still occasionally used to test for ammonia owing to its tendency to form the deeply colored iodide salt of Millen's base. Mercury fulminate is a detonator widely used in explosives. Higher oxidation states. Oxidation states above +2 in a non-charged species are extremely rare, although a cyclic mercurinium cation, with 3 substituents, may be an intermediate in oxymercuration reactions. In 2007, a report of synthesis of a mercury compound, mercury fluoride, was published. In the 1970s, there was a claim on synthesis of a mercury compound, but it is now thought to be false. Organomercury compounds. Organic mercury compounds are historically important but are of little industrial value in the Western world. Mercury salts are a rare example of simple metal complexes that react directly with aromatic rings. Organomercury compounds are always divalent and usually two-coordinate and linear geometry. Unlike organocadmium and organozinc compounds, organomercury compounds do not react with water. They usually have the formula Hgr2, which are often volatile, or Hgrx, which are often solids, where R is aryl or alkyl and X is usually halide or acetate. Methylmercury, a generic term for compounds with the formula CH3HGX, is a dangerous family of compounds that are often found in polluted water. They arise by a process known as biomethylation.